You can only add radical expressions that have the same index and radicand. For example, if I have the cube root of 2 plus the square root of 2, that cannot be added because the indexes are different. If I have the cube root of 2 plus the cube root of 3, those cannot be added even though the indices are the same. What's wrong? The radicand is not. Now, if I have 3 cube root of 2 minus 4 cube root of 2, you know, it's like adding like terms in variables. This is, if this is like an x, that would be like an x. Oh, they're right there. See them? Yeah, we're overflowing. All right, so this is, so when you do this, this is treated like a variable. You're going to have 3 take away 4, which is negative cube root of 2. Done. So, but to think that they're going to give you the same radicand is a pipe dream. If the indexes are the same, but the radicands are different, what do you have to do? You have to simplify like you've done on the last 2 days, all radicals first. Then see what can be added or subtracted. So this is where yesterday and the day before come in. These are roots, square roots. So how does the square root of 24 simplify? So that's going to be 8 times 3. What is 54? That's 72. 48. Getting closer. 56. That's even closer. 6 times 9. So we're going to say this is 4 times 2 times 3. Now, do you see a perfect square in here, or do you want to factor it further?
A perfect square.
What's the square root of 9? 3. Now, what is 6? It's 1, 2, and it's 1, 3. Will that simplify? No. Do you see a perfect square here? What's the square root of 4? So you have 4 times 2 times the square root of, that's gone. There's not 2 2's, there's not 2 3's. We put it back together. What's 3 times 3 on the outside?
9.
So you've got 9 square root of 6, and this is going to be 8 square root of 6. Now, are the radicand and indices the same? So what is that? 17 square root of 6. That wasn't bad, was it? Now our cube root. So what do we do first? What multiplies to give you 16? X to the 4th minus 2 cube root of 2x to the 7th. All right, so we're going to take this one further, because how many do we need to come out whole? 3. How many am I going to have? 4. Do I need to expand the x, or will we be able to do it without that? Okay, so let's go ahead, bless you, let's go ahead and fix this one. How many groups of 3 are in 7? 2. With how many left over? Okay, so now what can come out of here? 1, 2. So we're going to have 3 times 2. How many groups of 3 are in x to the 4th? 1, leaving you with what? 1, 2, and 1x. Cube root of x. So this is going to be 6x cube root of 2x plus 2x squared. Oh, I forgot the 2. Pardon? Good question. I'm confusing? Why? Sorry. All right. What's good about this problem? What's bad about this problem? No. Does the outside match? Can we add those? You know what we could do, though? We could factor out cube root of 2x, leaving us with what? Come on, 6x, what? Minus 2x squared. Heck, while we were factoring, what else could we have factored? Heck yeah, a 2 and an x, couldn't we? Let's factor out a 2 and an x. Then what do we have? 3 minus what? X. So that's something we could do. But otherwise, we can't take that any further.
Okay, so do we just do what's highlighted on the test, or I say what's highlighted?
Say that?
Yeah.
You think that's enough?
Yeah.
Probably. All right. How do we do this one? Yes.
Because how did you?
Are you with me to hear? Oh.
I put a x cubed instead of an x squared.
Okay. Are there 4 factors of anything underneath here? Are my indices good? Can I subtract them? No, why not? Because the radicand is not the same. So does that problem stay just as it is?
Yeah.
Yep. All right, so now let's look at this one. What about this one? Why? Right, not the same. Let's see if I did better on this one. Are there 3 groups of x's?
No.
Are there 3 groups of y? So is there anything I can do with the front part? So that's going to be 2 cube root of x squared y minus, what's the cube root of 8? How many groups of 3 are in x to the 5th? 1. How many groups of 3 are in y to the 4th? Leaving us with how many x's and how many y's? Do my radicands and my indices match? So that's so far so good. What's the problem? Yeah, you can't add them because those are different. Can we factor though?
No.
Oh, let's try.
Wait, I understand like you can't add them because they're different.
Okay, what if we had this?
What if they like?
Can you add those? That's why.
Okay, but what if they were the same?
So if this had just been a 2, that would have been 0. If that had been an 8, that would be 2 minus 8, which is negative 6.
What if it was 2? Like, what if it was just 2? Or plus, like, 2 cube root of x squared y plus 2 cube root of x squared y.
Yes, you could add those, yes.
That's 4.
Yes. So I've really written some really nasty, ugly, dead-end problems, shall we say. The book did a much better job than I did. All right, so what are you going to do here? Anybody have a textbook? Thank you. There's one up here. What's the syllabus say? I want to make sure. 31 through 53.
All?
Wait a minute, this is on 7.3, right? Not 7.4. 31 to 53. Oh, that's just a review. All right.
Is it all or odd?
All are odd. All. So, guess what? I don't need to go there today. Is that a good thing?
Yeah.
And so I'm finished with what I need to do.
Okay, let's do go backwards.
Yes, I can go back one slide. But I can't find my slate. All right, back one slide. Yes. All right, so would you like the book?